The purpose of this video is to introduce to my students adding and subtracting fractions with like and unlike denominators. This lesson can be found on beginning on page 137 of our students' text books out of the Carnegie Learning Series. Now, I'm actually making this video because I'm not going to be at school tomorrow, and I thought it would be very helpful for the substitute teacher to go along with this lesson if she could play the video in my absence. Now, I would recommend that the class or individual students, if they're working on this at home, read everything on page 167. I would also encourage you to read everything on page 168. I'm going to be picking up this lesson beginning at problem set 1 on page 168. Now, in the book it tells us that there are many ways to represent 1, and it offers a suggestion that students use their fraction strips, fraction strips that we created in an earlier lesson, to show that there are many ways that we can create 1. Now, I'm going to add to this fraction strip some color to show that there are different ways that equal 1. Now, this top bar here, this beginning bar that we have, it is a value of a whole. It's one whole bar. It's not been divided into sections or anything. This is a whole. And as long as we get our fraction sentence to start flush with the left margin and go all the way to the right margin, we have created a whole. One of the easiest ways to do that would be perhaps to shade in this half and then these 2/4. By shading those in, you can clearly see that they stretch all the way across and they produce a fraction that equals 1. So I'll go ahead and write that down just as an example for my students. So you could have, we'll call this one A, 1 equals, and here we have 1/2 plus 1/4 plus 1/4. Now, I'll do another one this time, and I'm going to go ahead and clear out my shading for these. I'm going to clear out that shading. I don't need any shading there. This time I'm going to go ahead and I'll use perhaps the half once again, and this time I'll just use a blue. And then I'll highlight perhaps these 1/8, and it takes 4 of those eighths to equal the whole along with the half. So for this one, I could write down 1, and I'll just call this one B, and I'll say 1 is equal to 1/2 plus 1/8 plus 1/8 plus 1/8 plus 1/8. Now, I think that this is completely within the realm of my students, whether they're at home working on this by themselves or if they are with a substitute, to do a few of these examples on their own. So at this point, I'm going to go ahead and put a place for C and D, E, and F, and the substitute can pause the video long enough for students in their groups to complete other examples that show how fractions with different denominators, in this case we have a denominator of 2, here we have a denominator of 8, can equal a whole. Okay, I'm going to assume that students have completed that activity, so now I'm going to go ahead and move on and talk about denominators. Now, denominators when we look at our definition in our book on page 168, it tells us that if the denominators are the same in our fractions, they have a common denominator. A common denominator is a whole number that is a common multiple of the denominators of the fractions. There's also what we call the least common denominator. Now, the least common denominator is the least common multiple of the denominators of two or more numbers. Now, if we were to look for common denominators, or at least common denominators, with our fractions, we'll say this one here. We'll work on this one for A. We have 1 equals 1/2 plus 1/4 plus 1/4. If we wanted to have like denominators here, all we would have to do is come up with an equivalent fraction, something that we learned in a previous lesson, that an equivalent fraction that would equal the same value as 1/2, yet have the same denominator as the 4 and the 4 here. Now, this might be a good introduction for page 169, the lessons there. But I'm just going to go ahead and write my example here, and I'm going to say 1 equals. Now, I know that 2 is a factor of 4, and 4 is a multiple of 2. So I'm going to just go across the board and say 4, and 2 can go into 4 2 times. So 2 times 2 is 4, and I must multiply my numerator by the same number that I multiply the denominator by. So if 2 times 2 is 4, then I have to say 1 times 2. 1 times 2, of course, is 2. So 2/4 plus 1/4 plus 1/4, sure enough, equals a whole. In this case, 1 plus 1 is 2, and 2 plus 2 is 4, and so 4 over 4 is equal to 1. 4 over 4 is a form of 1, and this is something that we learned in a previous lesson. Anytime you have your numerator the same as your denominator, you have a fraction that is a form of 1. It is equal to 1. Let's look at B. Now this, once again, could be a good example for B, which students will have to complete on page 169. In this case, we have 8s with all of our denominators here. These are all 8s, and then here we have a 2. Now I know that 2 is a factor of 8, and 8 is a multiple of 2. So 8 will be our least common denominator. So I'm going to go ahead and put 8 as my denominator here, and I know that I have to multiply 2 by 4 to get 8. 2 times 4 equals 8. So if I multiply my denominator by 4, I must multiply my numerator by 4. 1 times 4 is 4. So 4/8 is equivalent to 1/2. It's the same value. And then I just simply write down these other 8s. So 4/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8. All equals a whole, because 1 plus 1 plus 1 plus 1 equals 4, and 4 plus 4 equals 8. And 8 over 8 is a form of 1. It is equal to 1. Now I do want to point something out right now. Whenever you are adding or subtracting fractions, you do need to have like denominators, and that like denominator could be a common denominator, or it could be a least common denominator. Now, if we were sloppy with our work, I know this looks kind of messy, my handwriting, but I mean, if we were careless about coming up with a least common denominator, and we just wanted to have all of our fractions have the same denominator, we might would have chosen 16, or we could have chosen 24, but that would have been a whole lot more work. We would have had to have come up with equivalent fractions for all these, and it's so much simpler if you do a least common denominator. Now, the substitute may would like to pause this video just long enough for my students to complete page 169, whereby they give all of their fraction sentences, such as these, like denominators, such as these. Okay, I feel like there's enough time has passed for the video to have been paused and restart again. So I'm going to clear my board. And I'm going to look over on page 170. And I'll briefly go over the directions. Number 1 says, the teachers at Riverside Middle School decide to make trail mix for an upcoming field trip to the Natural History Museum. They have decided on 3 different recipes, and they have 3 recipes in the students' books. For copyright reasons, I hate to show a PDF file of this page. I hate to actually read it directly from it, but I feel like for educational purposes, and we paid for the series, I feel like if I at least read it to them, it might not be that bad. So A says, how many cups of raisins are needed to make 1 batch of each trail mix? Well, in this question, students can refer to the recipes for the trail mix and find where it lists raisins. I know that raisins are included in the recipe for the sweet and nutty trail mix, and raisins are included in the recipe for the fruity trail mix. Now, I'm not going to write down the exact fractions that Carnegie provides because I just want to do it as an example. But for A, just to come up with any example of 2 fractions with different denominators, I'm going to just write down, let's say that we have 3/4 in one of the recipes, and in the other recipes it calls for, we'll say, 2/3 cups. Now, we're essentially going to have to add these 2 fractions together, but the way that we can do this is provide the denominators a least common denominator. Now, I know that a multiple of both 4 and 3 is 12, and that's about the least common denominator. Well, that is the least common denominator that they have. So I'm going to put 12 for one of them, and I'm going to put 12 for the other one. Now, 4 times 3 gives me 12. So if I times 4 by 3 to get 12, I have to multiply 3 by 3. Alright, so 3 times 3 is 9. And I know 3 times 4 gives me 12, and if I multiply the denominator by 4, I must multiply the numerator by 4. 2 times 4 is 8. So what we have here now are like denominators, and my denominators are not going to change. I'm not going to say 12 plus 12 equals 24. I'm just going to say 12. Now 9 plus 8, that's going to give us 17. What we have now is an improper fraction. Now, anytime you have an improper fraction, you can convert it to a mixed fraction. The fraction bar, the operation that it symbolizes is division. So I can divide 17 by 12, and that will give me my mixed number. I can say 17 divided by 12 will give me 1. 1 times 12 is 12. I'm sorry, my control over this is not as good as I would like for it to be. 7 take away 2 will give me 5, and they cancel each other out. So I have a remainder of 5. Now, when you have this done, all you have to do is think my quotient, my whole number, 1, is going to be the number in this mixed number. 12 remains as my denominator. That did not change. The remainder becomes my new numerator. So that 5 is going to be my new numerator. So if we were looking at a recipe and another recipe that both called for raisins, and one of those recipes called for 3/4 cups of raisins and one called for 2/3 cup of raisins, then we could come up with equivalent fractions with least common denominators and eventually arrive at a mixed number of 1 5/12 cups total of raisins. Now, I'm going to switch over a few things. The reason I'm going to do this is I don't want to get too far away, too far into this while I'm not present, and I'm going to pause it at this point and go over the homework assignment.